Hey, welcome back to Math with Patrick. Today's September 13th, and we're solving problem 256 from the Daily Epsilon calendar. And we need to figure out why this question's answer is 13, because the answer always matches the day's date. So a class averaged 6 out of 20 on a quiz. That's kind of bad. So the teacher gave half credit on all missed questions. What is the adjusted average? All right, this question is pretty open-ended, I would say, for two reasons. The first reason is we don't actually know how many students there are in the class, and I'm pretty sure it doesn't actually matter. And so maybe I'll do an example with just one student in the class and see what happens, and then we could try something a bit more complicated with like 3 or 4 students. And then also, if we imagine the scenario where we have more students, um, another bit of like ambiguity is that we only have the class average of 6 out of 20. It's totally possible that some kids scored really well, like maybe like an 18 out of 20, but then the other students would have to compensate and get lower scores so that their average is 6. So let's explore some of these options. Like, what if there's just one kid in the class? Like, that's possible, right? It doesn't say that it couldn't be. So if we have one kid in the class, we could maybe take a look at their score, maybe visually. We could get 20 points over here, 0 over here. And so 6 would be like right around there-ish. And here, if we get half credit on all missed questions, we can look at these ones, which the kid missed. There's 14 of them here. And so if each of these questions gets half credit, then there's 7 points total. So there were 6 points, 6 correct questions already. Adding the 7 additional kind of freebie points, we do get 13. And this right here is a totally acceptable answer to this problem. Sometimes when you're offered this kind of flexibility and there's no like rule that tells you that you can't pick just one student in the class, sometimes this is the best way to solve the problem. You don't need to make it more complicated, but just to show that other scenarios still produce the 13, let's take a look at, say, 4 students in the class and think about like what could possibly happen with a slightly more complicated scenario. So let's, draw 4 bars to represent the scores of the students. And sure, an example of a possibility is all students score 6, but it is totally possible that the actual scores of these students, vary as long as the average is 6. So let's create an example together that, has some kind of varying numbers and then just kind of see if we still get the 13 or not, and we still should. I think the idea is that let's just try to figure it out. So maybe let's set one of these kids at 6. Why not? So this kid right here has 6 points. But then this one, maybe this kid does a bit better and they have 10. And so I just upped their score by +4. And so to compensate, I need these 2 students to have a -4 so that the average still remains at 6. And so what's kind of funny is I could maybe give this kid like a +2 maybe, and this kid could flunk it. That's actually kind of fun. Let's do it that way. So this kid goes from 6 to 8 now, so that's a +2. And so to make sure that everything stays balanced, to make sure our average still stays at 6, then this kid has to go -6, and then they scored a 0. Just to show that the average is still 6, we could add up all their scores, 6, 10, 8, and 0, divide it by the amount of students that there are, which is 4. This numerator right here, I'm seeing a 14 right here, plus 10 is 24, divided by 4, and we still get 6 as our average. All right, now let's see what happens when we give them some bonus points. Well, this kid would still get that 13, kind of like how we saw from earlier. Now that this kid's at a 10, looks like they will go up to a 15. Since this kid's at an 8, there's 12 points left over, so half of that is 6. So this kid will go up to a 14. And then this kid gets 10 free points, and they go up to a 10. So here are their new kind of adjusted scores here. So one thing I'm noticing is like this kind of normal scenario, normally you get a +7. But then as we're kind of, fudging the numbers and trying to like introduce a little bit of variability in here, this +4 right here makes the amount of kind of makeup points that we get less. Here we added 5. And so the rule here I'm seeing is that normally we add 7 in this scenario. But if we're adding on extra points kind of to begin with, some correct questions, this value here gets decreased by half of what we added on here. And so that's why we went from 7 to 5, because that's half of this 4. That's why we went from 7 to a +6 right here. That's half of this 2. And then conversely, we are adding even more bonus points to this student. So since they were, 6 fewer questions than the average, that would suggest that we would add on 3 more bonus points than the average kid of this +7 right here. So as we added or subtracted scores to kind of play around with, different scores and keeping the average at 6, kind of the logic behind keeping the average at 6 also kind of keeps these values in check with just this +7. So on average, actually I shouldn't have circled that +3, I should have circled the +10. On average, the score increases are still +7 across the board, right? We could go 7, +5, +6, +10, divided by 4. But I mean, here, to me, it makes more sense to think that if I donate a 1 to this 6 and a 2 to that 5, then I'd get 7 here, and then I donated 3 away from the 10, and so I'd get another 7 right there. So every student gets, on average, 7 of these kind of extra credit points. So it doesn't matter what happens once we shake up all the numbers. We're still going to find the average of 13, right? The first student got a 13, the next student got a 15, the next student got a 14, the next student got a 10. We could divide this all by 4. Let's see, there's 10, 20, 30, 40, 49, and then 52. And then if we divide 52 by 4, we do get 13. So even if we play around with the numbers and do something a little bit more complicated, the fact that the average must be 6 just kind of like locks us into the scenario that once we allocate these half credit points, we're still going to end up with a class average of 13. So there's my solution. Maybe there's a way to do it with like algebra and variables, but I figured like, let's just assign some numbers to it, play around with it, figure out the logic, and we can figure out that kind of no matter what, we're stuck with the number 13. So that's today's date. So it all works out, and we're all done with the video. Thanks for watching, and I'll see you tomorrow. Bye.